So you will have a mathematical problem to, again, apply what I just showed you, but what if you were given a graph and it says use the accompanying graph of f, which you have 4 here, it's the same graph, to estimate all c values that are stated that satisfy the conclusion of the MVT or Rolle's theorem. So we need to state whether it's MVT or Rolle's. So first of all, what we have to look at is what is the interval. So I'm just going to do 2 of these, and I'll leave the other 2 for you. But what we're looking at is, in this case, the interval from -3 to 1. So these are my x values here. And we're going from -3, okay, which is right here on the graph, to 1, which is about right here on the graph. So what we want to do, just like in the previous graphs on page 24, I want to connect these 2 points, these 2 green points. So what I'm going to do is just use a ruler, and I'm going to connect these 2 points like this and see what I'm looking at in terms of a slope. So the difference between MVT and Rolle's is that for Rolle's, the slope has to be 0. I'm looking at the slope. This right here represents the slope of the secant line. Okay, this is clearly not 0. So if it's not 0, we're dealing with the MVT. If this was a horizontal line, then it would be Rolle's. So now what I need to do is identify where on this graph, where could I draw on this interval tangent lines to the graph that would have a similar slope. I see 3. 1 here. I mean, literally so close, so I'll do it in red. And then I go right here, and I'm just leaving my ruler on the same angle right here. And then this is on the interval also, so right here. I'm not going to go out here because it's outside the interval, and this one is also outside the interval. So what they're asking in this question is, what are those c values, meaning the other x values where this occurs? So I'm going to say c sub 1, c sub 2, and c sub 3 are equal to what values, meaning what's the x value? And again, we're approximating. So if this is 1, 2, 3, 4, okay, these are worth 2/10, I think. Here, this is where x is equal to 0. Okay, and they're calling this c because remember it's on the interval from a to b. Okay, so then here we would say this is -1.24, maybe? -1.4, -1.5. It's an estimation, so it's going to be pretty close. And then c sub 3 here, so this is -2. So when I come down, I don't know, 2, 4, 5, or 6. So -2.6 or -2.5, whatever you wrote. So this is the MVT because the slope of the secant line is not 0. So let's take a look at this example right here. First of all, we want to look on the interval from -3 to 3. So here is my A value, here is my B value, and what I want to do is connect those 2 dots. Well, take a look. What is the slope of the secant line? I hope you're saying with me, oh, it's 0. So this is clearly Rolle's. Why? Because the slope of the secant line is equal to 0. Okay? So now I need to identify where and how many places on the graph did that happen. So first of all, when I look at this, there's a lot. 1, 2, 3, 4, 5. So I've got 5 values I have to identify. So I'm just going to draw them on the graph, which is what I would expect you to do. Okay, this is page 26 also in the note packet. So we have c sub 1, c sub 2, c sub 3, c sub 4, c sub 5. And these all just represent the multiple x values where I have a horizontal tangent line. So I usually just go from left to right. This one was the same one that we talked about before. It's about -2.6. This one right here we could say is -1.4, -1.3. Whatever you say. This one right here would be 1.2 or 3. Oh, I missed one. Dead smack in the middle here. Right here. Oops. So this isn't exactly 0, so maybe -0.2. And then this last one is at 2, 4, 6. 7, maybe 8. So 2.7, 2.8, it just depends. You're estimating, it's an estimation, don't freak out. Okay, so that's how you would apply that.